All right, so in the first thing that we made, we traded our motor's torque or rotational pushing strength for speed. We used a big gear to push a small gear. Every time the big gear turned around once, the small gear had to turn around many times to keep up with all those teeth. And so we traded torque for speed. And then in the second build, we traded speed of our motor in for more power on the output shaft. So we had a motor that spins fast, and every time it goes around, it doesn't even turn it once. So it takes many times around to turn this motor, which means you're taking all that work and saving it up for something that doesn't move very fast or do much work at all, which means it's going to be very powerful with high torque. So we trade speed for torque, just the opposite. What happens though is what if we wanted to drive another gear, but we didn't want to make a trade and we just wanted to have the same output? So same speed, same torque on the output. That's called neutral gearing, and we're going to do that right now. First of all, let's look at our bill of materials, what we're going to need to make this. So you're going to need 2 of the large 36 tooth gears, 2 of the shafts. These are 9 long. You could go longer than that, maybe a little shorter, but I don't think so. We've got these 2 spacers to hold the shafts so that they don't fall out, and then 2 turn indicators. You know, many different things can work for that, but I'm using these wire clips because they're smaller and less likely to run into each other. All right, so let's get going, and we're going to build this one right now. First of all, start off, let's install the shaft, and for ours it was 3 down and 3 over. Whatever it is, it has to match up so that it runs into the motor. All right. Whoop, too much. And then you're going to slide that over so that it can't fall out of there. We're going to add a 36 tooth gear right on there and a turn indicator so we can actually see that it's moving and what direction. Okay, we're going to do another one of these with a turn indicator. So a 36 tooth gear with some sort of indicator. And this one's going to be a little bit different. Instead of going straight across, we're actually going to go down. From this shaft, we're going to go 1, 2, 3, 4 down, and then 1, 2 over. And if you do it right, it should mesh. If you've put it in the wrong spot, you'll notice that it won't mesh. Or it just won't even go on there because it's too close. So there it is. Shh. All right, and then we're going to put this on the back so that the shaft doesn't fall out. So if you have it right, it should be down 4 over 2, and it should mesh. The main thing to look for is just use it, and it should mesh. If it doesn't mesh, you got it wrong. All right, so now instead of going straight across or straight down, we've kind of got it at a bit of an angle there. All right, so let's take a look at this and what we've accomplished. So you can see the math behind it is 36 divided by 36. And anytime you have any number that's divided by itself, the ratio there is 1. So what that means is what we should see here is, yeah, they're meshed together, so they're going to go in opposite directions, clockwise to counterclockwise or vice versa. And we should also see that every time this one spins around one time, or excuse me, the motor spins around once, the output shaft should also spin around exactly 1 time. So let's check it out. So you have 2 of these that are spinning at exactly the same speed. So we aren't trading power for torque for speed or speed for torque. Or you could think of it as we're trading equal torque for equal torque and equal speed for equal speed. So why would you want to do this if you're not going to gain or lose speed or torque? Well, if you wanted to move and locate it in another direction, so you needed it, instead of coming out here, you needed it down here around a corner or something that's in the way, you could use neutral gearing for that. Perhaps you need it to reverse the direction. So you have a motor that's spinning one way, and for this part, you need this thing to spin the opposite direction. Or you just, so there's a few reasons why you might want to do this. If you were to put 2 of these in a row together, you could actually chain these together to go the opposite of the opposite so that three of them, the third one and the first one go in the same direction. There's all kinds of ways that you could use this. Anyhow, when you're done with this, show me your results for neutral gearing. Thank you.